Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering, drawing and computer graphics. We are in module number 2 and lecture number 20. In this we are completing the conic sections part. How to construct a conical helix over a cone. So, if we are winding a rope or thread around a cone starting all the way from apex to base, the geometric curve we get is called conical helix. For example, let us look at a conical helix winded around a cone of base 70 mm and height 90 mm. And it has made one revolution starting from base all the way to top one, the peak. So, to do that, first of all we have to construct a cone in the frontal view, which we will get as a triangle. First we have to construct a triangle of required base and height. In one of the view, if we are looking at from bottom, it looks like a circle. So, one of the view is circle we have to construct. Of same diameter. Then divide the circle into 8 equal parts. Number them 1, 2, 3, 4, 5, 6, 7 and 8. After that, divide this cone height also all the way from P to height H into 8 equal parts. This one also divide into 8 equal parts by drawing horizontal lines all the way up to there. Then number them as 0.1, 2, 3 all the way to 8. Now, from these labels 1, 2, 3, 4, 5, 6, 7, 8 of the circle, extend the lines which are going to generate lines on the cones. So, these are called generator lines of the cone. So, let us consider one of the particular line. We would like to construct a generator at this point. To do that, if we are extending 3 line all the way to 5, the place where it is going to cut the base, from there connect the point all the way to peak or apex. So, this is the way we will construct one of the generator. Similarly, from 2 extend all the way to that point, from that point to 8 apex, if we are connecting another generator we can construct. Similarly, a line extending all the way from 1 to 7 cuts this cone at this base, connect this base with 8. This is the way first of all we have to construct the generators of the cone and also equal number of divisions on that cone. Once it is done, we will construct points or the winded rope around this cone in the frontal view. So, at this front view, we extend this 8 point, going to make a point at P level at P level, make a dot. Similarly, if we are going the intersection line of this one equal division and a line which is passing through one point, that is also going to make a point P 1. Once it is done, from second extend a line and a horizontal line where it is going to intersect, locate point P 2. The horizontal line P 3 on generator 3. So, this is the line where it is going to intersect, extend it, so that we are going to make another point P 3. Similarly, P 4 where fourth one and generator line going to intersect. Fifth generator line is passing through this point and fifth one intersecting point that. So, in that way we will construct, we locate points P 1, 2, 3, 4, 5, 6, 7, 8. So, for the top one we always have to intersect generator line and the equal division made on one of the generator. So, equal division made by one of the generator is this one intersecting with generator line 1. So, in that way we will construct all these stop points. Once these stop points are done, we can make a freehand sketch passing through P 1, P 2, P 3, P 4, takes a turn, goes via that. This is the way we construct a conical helix winding a cone on the top side. For the bottom also, bottom view, from P, if we are dropping a perpendicular line, is going to intersect the first line at this point, locate that first point P 1. Extend this P 2 all the way from one of the generator line. Once it is done, from center make an arc which is going to intersect this point, call it as P 2. For P 3 also drop a perpendicular, so that it is going to intersect the 3 line, call that P 3. For P 4 drop a line where it is intersecting, call that point as P 4. Similarly, from point P 5 extend it all the way down, it is going to intersect there. So, call that point P 5. For P 6 drop a line from one of the generator all the way to N with equal radius from O to this point, make an arc, locate P 6. P 7 extend the line all the way down, is going to intersect at that point. In that way we will construct points P 1, P 2, P 3 in the bottom view also. Then draw line passing through these points. This is the way from top view the conical helix looks like. Let us do that, these steps on a graphical sheet. First we have to construct a circle of diameter 70 mm. So, locate a point of 35 mm, 0, 35 mm. this is let us extend the scale so that we can draw a tangent to that circle. Parallel to that, we have to move to construct parallel lines. Similarly, draw one more parallel line all the way up. Locate apex on these lines from any base. Let us join the base line. So, let us make it the cone base is this. This is the starting point, end point, let us call P. We have to locate 90 mm as height for the cone. Join these endpoints. To construct one of the view of a cone, which looks like a triangle. Now, divide this cone slant thing into equal number of parts. Let us use this projected line into equal number of parts. Use compass, make 8 equal divisions. 1, 2, 3, 4, 5, 6th one, 7th and 8. Name these points 1 prime, 2 prime, 3, 4 prime, 5 prime, 6, 7 prime, 8 prime. Now, join the last point with the peak or apex of that cone. Parallel to that, construct so we need parallel lines. So that other divisional lines we will be in a position to construct it. Draw parallel. Now, name these as 1, 2, third point, 4, 5, 6, 7 and 8th point. 8 divisions are done. Now, divide the circle into 8 equal parts. Four parts are done. Locate 45-degree angle. on both sides, join it by a line. Now, name them 1, 2, 3, 4, 5, 6, 7 and 8. Draw a line which pass perpendicular to these points. So, which will be connecting this first point, third point. So, it cuts the axis at this point. Similarly, extend 2 to 6 all the way up along this line. Similarly, extend 1 and 7th point. Now, draw horizontal lines passing through 1, 2, 3 on this cone. So, these are the lines which are going to intersect the generatrix. Now, locate the intersection points for this generatrix. So, the first one is intersecting at this point 1, join that with apex. Similarly, join fifth one 2.8. Now, the intersection points for 8 to P is P. So, let us use red color ink. First point, that is our P. The second point where this generatrix horizontal line intersecting is P 1. Similarly, the generatrix and this line horizontal one intersecting at P 2. Extend 3 which is going to intersect 3 goes via this generatrix intersecting at P 3. Fourth line via generatrix intersects at this P 4. Fifth line again it intersects here. Sixth one passes via this point P 6 and seventh line it passes via this generatrix here, and eighth one passes via this generatrix P 8. Now, join these lines by a freehand curve. When a rope is winded around a cone, the front part of that rope will be visible. While it is winding the back side of the cone, it will be invisible at first front. Though it is there, it is invisible for us. So, such kind of lines, invisible things, but still present, we show it by dashed lines. So, let us connect from P 4 onwards, it goes back and try to wind. So, we show it by dashed lines. So, a dash line pass through that. Now, make a color. So, our conical helix looks in that way on the frontal view. So, let us do that for the bottom part of that curve also. From top view, if we are looking from top view in this direction, how does that helix wind on that plane? Let us draw that. So, the intersection points are at this P1, P2, P3, P4 and so on. So, the projections what we are going to get here goes via these bottommost points. So, let us move parallel to this plane. Intersect P1 all the way to first generatrix, here located by a red line. So, the first point is here P again, this one is P1. Let us just use primes for this P1 prime. Second one, it goes via generatrix. So, move parallel to 2, make it onto horizontal line. From there, take a compass, make an arc onto second one, it is intersecting here, call that one P2 prime. Now, move parallel to 3, it intersects here, call that point P3 prime. Similarly, pass parallel to this fourth line. It intersects on 4 here. So, let us call P4 prime. Similarly, pass parallel to 5. It is intersecting at this point P5 prime. For 6 again, it goes via this point. However, we want pressurized measurement which is going parallel to this 6. So, we intersect the horizontal one, measure the distance of this point on that axis. It makes here, connect this point as P6 prime. P7 it pass via 7, it intersects this point, call this one P7 prime, and P8 anyway here. Now, join these, because we are looking from top view in that direction. So, entire row will be visible. So, on this view it will be a continuous line. From top we are looking and trying to show it on this horizontal plane. So, join by a smooth freehand curve which pass through P4, P5, P6, P7 and P8. Now, join this entirely by a continuous curve. To get a smooth curve, we can use French curves. So, this is what we call conical helix. Here it made one revolution. In certain cases, if we are making many more revolutions, similar procedure has to be followed. Instead of one revolution, if 2 revolutions are passing, we are going to extend this curve to 2 more revolutions, by dividing into many more number of parts and smoothly connecting it. With this, we are closing conical sections. In the next class onwards, we will learn more about these projections, like what is vertical plane, what is horizontal plane, how to visualize something in front view, something as top view, something as side view, and the directionality of these views. See you in the next class. Thank you.